There are two types of quantities that are important in physics. First one is scalar quantity that has only magnitude and needs no other information to specify them, like number of potatoes in a box, mass of an object, and temperature in your location. And the second one is a vector quantity. This requires magnitude and direction to specify them, like velocity. This block is moving with a speed of 2 meters per second. Only the speed of block is not enough to describe its motion. So we have to tell in which direction it is moving, left or right. So velocity requires directions too, along with the magnitude. Momentum, that is mass times velocity. Force, whether you are pulling the door or pushing the door. Displacement, suppose you are at home and you went to market, which is 5 kilometers away from your house. Then you can be on the circumference of a circle having a radius of 5 kilometers. You can be in this place, or in this place, or in this place. So to know your displacement or position, you require directions along with how much you are away from a reference point, that is home. These are vector quantities. To give a sense of direction, we need a vector quantity. Now we will learn different types of vector, like unit vector, position vector, and velocity vector that we will need frequently throughout the course. Suppose we have a two-dimensional space and you want to go from point O to point B following the steps in x and y direction. So you take the first unit step in x direction. That unit step in x direction is x cap. You took 3 similar unit steps to reach point A, and now you take unit step in y direction. That unit step in y direction is y cap. You took 2 similar unit steps to reach point B. Finally, to reach point B, you traveled 3 steps in x and 2 steps in y direction. OB vector can be written as a sum of vector OA and vector AB. Here, OA is 3x cap and AB is 2y cap. So position vector of point B is 3x cap plus 2y cap. This representation of vector captures the information that how much point B is distant from the point O and also in what direction. If you pick the vector OB and place it somewhere else on a plane, then to go from tail O dash to head B dash, you will have to take 3 unit steps in x and 2 unit steps in y direction. If that's the case, then the vector OB and vector O dash B dash are same, and that is why vectors are movable. The moon travels around Earth once in 27 days in an elliptical orbit. Moon is responsible for high tides and low tides. If you take origin at the core of Earth and you draw a vector pointing to the current position of a moon, you will get a position vector at that moment. Here, position vectors are changing with time. Position vectors at any time can be derived from the analogy we discussed earlier. Start from the tail and move towards the head of the vector following the steps in x and y direction. Neeraj Chopra, Indian track and field athlete, won the gold medal in javelin throw in Olympic. Take one of the Neeraj's feet at a particular moment when he is just about to throw the spear as the origin, and connect the origin to the spear's midpoint at any point of time. This is the position vector of spear at that moment. As the time passes, the spear will be at a different locations. So the length of position vector and direction in which it will point will be different. Position vector of a spear at any moment can be derived in the same way. Have you seen the SpaceX Falcon 9 launch? In a case if you have missed it, it's here.
3, 2, 1, 0. Ignition. Liftoff.
Take any point on the base as your origin and connect the origin to the center of mass of Falcon 9. This is the position vector of Falcon 9. You can see how the position vector is changing with time. Thank you.